Hello everyone, my name is Samuel Esong and welcome back to my YouTube channel. So in this video, we are going to look at Kubernetes deployment. In our previous video, we have learned about pods as the smallest unit of execution in Kubernetes. We have also learned about Kubernetes namespaces for logical separations. All right. Now let us ask ourselves a very important question. Pods are great, but what if a pod dies? Or what if I want multiple replicas of the same pod? How do I manage them easily? So this is where Kubernetes deployment comes in. So before we get right into it, please, if you are yet to subscribe to my YouTube channel, please do well to subscribe to my channel. And also, you can help me to spread the word, share this channel with your friends, and and please like this video and also comment on this video. Let us get right to it. So we understand that pods are ephemeral in nature. With ephemeral, I simply mean that if you create a pod manually and it dies for any reason, that pod is gone. All right. So now you don't want to manually recreate pods every time something fails. You also might want multiple replicas. You also might want multiple replicas or simply say multiple copies of the same pod running for the sake of load balancing. So deployment solves this issue. All right. So now a deployment is a declarative way to manage pod. So deployment ensures your pods are always running as you desire. It lets you do rolling updates without downtime, and it also allows rollback if something goes wrong. All right. Now let us look at the difference between pods and deployment. Now, for pod, you can use the imperative or the declarative method to create a pod. But with deployment, the declarative method is always recommended for, for deployment. All right. Then a pod does not have a self-healing capabilities by default. All right. But with a deployment, Kubernetes ensures that the desired state is equals to the actual state. All right. So rollback is not available for pods. All right. But rollback is available for deployment. Now let us look at why deployments are important. Now let us look at this scenario. You have a web application running. Let's assume this web application is running in a single pod. Suddenly, the pod crashes. All right. And the pod can crash due to traffic and some other things. All right. And now that the pod crashes, users are definitely blocked. So what this means is that you have to recreate the pod manually. So this is exactly why we use deployment. Now with deployment, you declare the desired state in a YAML file, and Kubernetes ensures reality matches the desired states. All right. So the deployment file becomes the single source of truth. So the deployment file becomes the single source of truth. All right. So Kubernetes will constantly check the cluster and ensure that your pod match what is in the deployment. So remember that the best way to create a deployment is always with a declarative method. All right. So now let us create a simple deployment running Nginx and let us see what happens. Again, you can go along with the Kubernetes documentation to create a, a deployment. All right. So you can search for Kubernetes deployment document. So again, let me emphasize that no one actually wants medals from cramming most of these things. No one wins a medal from cramming most of these things. All right. Understand how this thing works so that wherever you see it, you will be able to make changes to it based on your reference. So this is a simple deployment file. All right. So let us go through this line by line. So we already know that this is what the API version for our resource. So deployment belongs to the app/version1 API group. Now, the kind specifies that we are creating a deployment object. We saw this with pod, all right? So since we are creating a deployment, then this now becomes deployment and the metadata, all right? For the metadata, the name of our deployment is Nginx deployment, all right? Now, we look at the spec.replicas. If you see, the replicas here is what? 3. So Kubernetes will ensure that 3 pods are always in the running state. All right. So you can copy this deployment and apply it in your cluster. So I have a deployment here. So if I nano Nginx deployment, all right. So let me edit this to 3 replicas. And we can now apply our deployment. kubectl apply -f deployment. Sorry, Nginx deployment. That is the name of our file. So our deployment has now been created. All right. So if I do kubectl get deployment, I should see that our deployment has been created. And this is the desired state, which is 3, but none is available, all right? And 0 out of 3 is available. So let us get our deployment again, all right? So 1 pod is available, all right? And 2 is available, all right? So we now have our available pods, that is replicas, all right? So now the desired state is now equals to the actual state. So to see this, we can simply do, since deployment is what? Replicas of what? Pods. So kubectl get pods. So we can now see that our pods are running. All right. Now, if you want to show more details, like the node these deployments are running, the nodes these pods are running, the IP and the status. All right, you can use the -o flag. All right, so this is the name of the pod. All right, then this is the IP address of the pod. All right. The node, of course, Minikube, because we are using the Minikube cluster. Okay. Now, here is the magic of deployment. Let me bring up another terminal so that we'll see this in practice. So I'll bring up another terminal. All right. So let me clear this for us. So kubectl get ports. So I'm going to use the -w flag so that we can watch what is happening in um in real time. Sorry, kubectl. So we can watch what is happening in real time. So I'm going to copy one of these ports, then try to delete this port, and we see what happens. All right, so kubectl delete port, then the name of the port. So if you check, one port is terminating, all right, but then the controller checks and found out that the actual state is not equals to the desired state. All right, so what happens is that Kubernetes is going to create another pod to complement the lost pod. So if you check, it started creating another container for us, all right, and the container creation was completed, and now our pod is in a running state. So if I do kubectl get pods, I can see that our pod is Kubernetes created another pod for us to complement the deleted pod. So if you check, we deleted the first guy out, and of course, it has created another one for us with another name. All right. So we have seen that Kubernetes automatically recreated a new pod to maintain the 3 replicas. All right. So the deployment file, it is the single source of truth. All right. So in the real sense, Kubernetes will always try to match the actual state to the desired state. All right. So this is the self-healing capability of Kubernetes. Now, we can also try to increase the replicas. Let us say 10 replicas. All right. kubectl apply. We apply again. All right. So if I come here, kubectl get ports, I can see that Kubernetes has tried to create the 10 replicas of my pod. All right. Of course, this is in a running state. This is a running state. This is in the running state. That is the first 3 that were already in the running state. So if I do get ports again, I should see that some of my, okay, it is still in the container creating state. All right. So some ports are now in the running state. All right. So give it some time, and we do kubectl get ports again. All right, so we are left with just 2 ports in the container creating stage. So we are left with 1 port in the container creating stage. All right, so now this is me trying to tell you that Kubernetes is always going to check your desired state to see if it actually matches with the actual stage. All right. So now we have all our ports in the running state. All right. So we can decrease the number of these replicas. Let's say 1. kubectl apply. We will see that if we do get ports, you will see that 9 ports are being terminated, leaving just 1 port, so that the actual state again is going to match our desired state. All right. So we have just one pod running. All right, because of our desired state. All right. So now we have seen that pods are ephemeral and deployments are self-healing. And we've seen how deployments can run multiple replicas. And we've also seen that if a pod dies, deployment creates the pod manually, sorry, automatically. And our declarative YAML file is what? The single source of truth. So we also saw the rolling updates. So we saw that when we added some pod, and also when we decreased the number of pod, we also saw that Kubernetes was gradually rolling out this deployment. All right. So this enables the users on the other end not to experience downtime with the application. All right. So Kubernetes terminates some pods manually while some were still running until the desired state matches the actual state. All right. So we have created a deployment declaratively. We started with 3 replicas, and we also saw that deleting a pod and will bring out the self-healing capabilities of Kubernetes. All right. Then we also updated the all right, okay. Let us see let us see the rolling updates in practice, so that you will really get to understand the. So for this, I am not going. Let me just update the Nginx image. All right. So I'm not going to use the latest Nginx image, but let me use this. All right. So we have updated our Nginx image. So let us see the rolling updates in practice. So we apply this again. All right. So you can see that we can see that the ports are updated gradually, one at a time, without downtime. All right. So this is rolling updates in action. All right. So we can see that the ports are updated gradually. Okay. So we can check when this is done. We will check our rollout status. All right. So the rollout status is just for us to check the progress of the updates. All right. To check our rollout status, I'll do kubectl get deployment, and this is the name of our deployment. All right. So to check the rollout status, I'll simply do kubectl rollout status, then deployment, then the deployment name. So if I hit enter, then can see that we are waiting for the deployment rollout to finish. All right. And 1 out of 3 replicas have been updated. All right. So this is how rollout works in real time. So we are waiting for this guy to finish. So let us check again. Waiting for deployment to finish, and 2 out of 3 replicas have been updated. All right. So 2 out of 3 replicas have been updated, and one old replicas is still pending termination. You remember that we had just 1 replica and we had to update it to 3 with the new Nginx image we updated. All right. So it's going to terminate that image gradually, and we can see that our rollout has been successful. So if we check the status again, our rollout is what? Successful. So if something goes wrong, you can always roll back to the previous deployment. So it's as simple as saying kubectl rollout undo your deployment name. So if I undo, our deployment has been rolled back. All right. So if I do kubectl get deployment, I can see that I have just one up to date. So let me check deployment again. All right. The 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 rollback is still in the undo state. It is not completed. All right. So if I do get ports, all right, so I can see that one container is still creating. Okay. All right. So the essence of undoing rollback is, let us assume you process a new update for your users and get to find out that there is a bug in your application. All right. You can immediately roll back to the previous version of your application. All right. Without your users experiencing downtime. So in the next video, we are going to look at services. All right. In the next video, we are going to look at services. So for your practice, create a deployment declaratively, check that the 3 replicas are running, delete a pod, and also see the Kubernetes self-heal. All right. Update deployment image for rolling back, and try to simulate that something is wrong and try to undo your rollback. So if you stayed with me up till the end of this video, then again, I appreciate you. So if you have any questions, you can drop it in the comments and I am going to reply each and every one of them. All right. So please don't forget to like this video. Don't forget to share this video. And please don't forget to subscribe to my channel. Thank you very much. I will see you in the next video.